thanks a lot, everybody. In terms of organization, all the person are in mute, so we will do this webinar on ArmoniK, and we will probably take something like 35 to 40 minutes to talk. First Jérôme and then Omar. And at the end, there will be Q&A session. So if during the presentation you have some questions, just write them in the chat. I will pick them and propose at the end to Jérôme or Omar to answer. So that was for the, let's say, for the logistic of this webinar. And now we'll jump into the core of the meeting. So we will talk about ArmoniK, which is an innovative orchestration open source, which offers cutting-edge high performance for quants and IT. And the people that will talk are myself just as a host at the beginning. Then Jérôme will speak from ANEO and Omar. So Jérôme, if you can introduce yourself.
Thank you, Thierry. I'm currently ArmoniK Tech Lead.
Okay. Omar.
Thank you. So I'm Omar Izwimi, and I'm in charge of the equity pricing services and analytics team within IT equity department at CA-CIB.
So during the course of this seminar, Jérôme will first introduce what is ArmoniK, what are the added value features that position ArmoniK as the natural replacement of existing closed source orchestrators like Symfony or Data Synapse. First, emphasizing the design choices that we've made. And then Omar from Crédit Agricole CIB will then explain how they have leveraged this feature and how they are currently running their risk on ArmoniK. My second slide. So I guess you all know Crédit Agricole because most of you are from banks. CA-CIB is the CIB arm of Crédit Agricole, French leader in banks, offering financial services. You see the number of employees, clients, and the number of assets that are real assets that are financed. And Omar is from Capital Markets IT, and you see below the footprint of this IT, which is quite impressive, more than 1,500 people spread all over the world with several tribes and quite a lot of applications. ANEO is probably the name that is new to you. We are a French consulting firm. I'm the CEO of this firm, and we are experts in CIB and HPC. We are doing turnover of 24 million euros with both in IT and management consulting, so not only technical stuff. And we declare ourselves as the European leader for HPC cloud, whether on integration services or optimization of setups. And we are the editor of ArmoniK, which is an open source that we have built in partnership with Crédit Agricole and AWS. So no surprise, Crédit Agricole uses it on AWS. And this is the way for us to anchor our leadership in HPC cloud for CIB. And you see below that we have a diverse and stable client base crossing several industries on top of banks, obviously. So that was it for the, let's say, the advertising moment. So I will hand over to Jérôme. So to explain ArmoniK, so I will mute myself if I found the button.
Okay. Thank you, Thierry.
We can't hear you, Jérôme, if you are speaking.
I'm not speaking yet.
Ah, sorry.
No, I'm trying to cut my speaker, but I don't see where it is. Bon, tant pis.
Yeah. So do you hear me now?
Yeah.
Hey, thank you, Thierry, for the introduction. As you're already familiar with, in CIBs, there is a lot of computations that you have to do, especially for intradays, end of days, and official mandatory batches. So there is a lot of computations that you have to orchestrate. That's very complex. There is a lot of computation. You have a lot of resources that you want to use to run those computations as fast as possible, because you have deadlines to respect. So you need a tool, an orchestrator, to help you to manage, to execute, and to monitor the computations on the grid resources that you have. However, the current middlewares like DataSynapse and Symfony are quite old. They offer quite limited features, actually. They help you to distribute your computations, but that's it. They do not manage data. They do not help you with that. You have to do it yourself. And if you want to implement complex algorithm on top of that, you basically have to reinvent the high-level APIs that you would like to use. And lastly, they are not well adapted to cloud computing. There is things that you can do with them in cloud, but it's not as seamless as you would like. So here it comes with ArmoniK, which is an orchestrator that has those features that are built for using into cloud and on-premises. It runs seamlessly on both infrastructures. We provide high-level interfaces that allow us to express more complex and more interesting computations more easily with graph and dynamism. And the tool is also open source, so that you can use it directly without paying any license. And we manage data and computation so that we can make the most of the available resources in terms of performances. So what are the goals that we had when we designed ArmoniK with CA-CIB? It was to go fast into production, to easily replace DataSynapse in Symfony, to make it easily accessible in terms of deployment into the IT systems and into the applications. We made it, we had the goal to make it stable into production, have good performances, and be portable, so that everyone can use it easily. So when I said that we need both the data and the computations to make the best of the performances that we can obtain from the infrastructures. So basically, we use your algorithm, the task that the tasks that you define, the computations that you want to make, the data that are used to make the computations on, and the infrastructure that will be used to execute the code, so that forms a graph of tasks and data that we can use to adapt resources in real time. So when there is computations to do, we use machines to do so. And when there is no more computations, we release the machines, so that in cloud, we only use machines when we need them. So we are able to target any infrastructure, whether it's on premises or in the cloud. And even in the cloud, we can use heterogeneous resources, meaning that we have a concept that is called partitions that allows the users to define a setup of machines that they want to use. Their setups can include GPUs, if you want to, CPUs, or RAM-optimized machines. So having the data and the computations, we can optimize the data transfers between the different instances, and we can do so also with the CPU usage. How to express a graph into ArmoniK is that it's basically data dependencies. So if you have a first task that produces data, an output, and this output is used as input another task, another computation, that will be the way to define dependencies inside a graph of tasks. So with this basic block, you can create any graph that you want to and that you need to. The specific is that the task will only be executed only when the inputs are available. So if the inputs are not there, the task will not be considered for orchestration. Only the tasks that can be executed because their inputs are there will be scheduled. There is also a second way to describe more complex graphs that are more dynamic. It looks like actually recursive functions, so that a task can create new tasks that will be executed later and delegate the production of the output so that you can create a first task that won't create the actual result, that it will submit new task, and another task will be will have the responsibility to create the output, and this allows us the ability to express very complex graph while keeping a very simple way to interact with ArmoniK. So if I can take an example that is more that's closer to what you have the habit to do. So as a user, if I want to price a portfolio, so inside the portfolio there will be many projects. So I can write a task that will have to price the entire portfolio, but since there is a lot of projects inside, you want to express as much parallelism as you want to. So this task can produce other tasks that will be responsible to compute the price of the project, and lastly, another task that will have the responsibility to aggregate the prices of each project and give the final result. And that's the previous way to explain graph into ArmoniK. And then you can also use multiple levels of this kind of capacity. If your project is more complicated, it can also create another set of tasks that will distribute the computations on multiple instances with an aggregation task that will have to produce the intermediate pricing. So if I link it to the partitions that we provide, we could make a few tasks running on the, for instance, CPUs optimized machines with a lot of RAM, and other tasks running on GPUs, for instance. We can also create tasks that will have the ability to run on preemptible instances. There are instances that are way cheaper in cloud, but that can be reclaimed at any time. I'll go back on that and explain what we can do with that. In terms of of optimization. As I said before, we are able to optimize the data transfer and the CPU usage in ArmoniK. The tasks are executed in what we call a worker that has the responsibility to execute tasks and run the code of the task on the data that will that is defined in the task. So during the computation of the task, we are able to prefetch and start the checks to validate that a task can be run. And when the first task finishes, we can start directly the new task without interruption on the worker side, so that the workers are all the time used, so that there is no way to get some kind of pause on the computations, so that the computation resources are always used. So that allows us to go to graph up to 50 million tasks and using 30,000 instances of worker. So that's the records that we got as of today. So we could be better, and if you want to, we can help you to break those records. So as I said before, we got a possibility to use preemptible instances so that these instances will be reclaimed by the provider. From the application side, it looks like a fault node that is disappearing. So we designed ArmoniK to be tolerant to this kind of issues, and we designed it to support the loss of all the computing nodes without failing the application. Meaning that if there is nodes that lost, we can start the computations again when it stopped. So when we lose resources, we can start again where it stopped when new resources are back again. So it fully leverages the preemptible instances that are way cheaper into the cloud. So how to get an idea of what's going on during the execution of tasks? We have a lot of UIs that can help you to understand what's going on. We also expose metrics with open telemetry that are standards, so that you can use them into your dashboards and monitor and give and get alerts when there is issues. We also provide APIs that we also use into our UIs, so that you can also access the data from ArmoniK, and we also provide the same kind of features at Data Synapse and Symfony. So thank you for your attention. I let Omar explain what they're doing at CA-CIB.
Thank you, Jérôme. So, so to start, and before talking about the integration of ArmoniK within CA-CIB system, in this slide, we'll elaborate the main challenges and the bottleneck that we were facing in our risk management and the pricing infrastructure at CA-CIB, and explain why the migration to ArmoniK was necessary and urgent. So just a few words about the business context. So we are talking about the pricing services. So this platform are used on daily basis by several teams across the bank. So we are talking about traders for their intraday and end-of-day P&L and risk. We are talking as well about sales teams that are calculation that they are calculating their RFQ and doing their client pricing. And we are talking as well about the risk department that relies on these pricing services for their P&L, sensitivity, stress test, VAR, SVAR, and cross VA. So as you can see, many critical departments relies on this platform to function properly. So to support all those operations, we were using a large number of on-premise grids. So each business line or asset class has its own set of computing resources. So for example, on fixed income side, we have up to 20,000 cores. On equity side, we have a set of 10,000 cores, and on risk, on counterparty risk and cross VA generally, so we have up to 10,000 cores. So each of those groups also has its own calculation orchestrator. So we have, and we had the data synapse for equity and counterparty risk, and we have IBM Symphony for IRD trading. So unfortunately, our legacy setup was reaching its limit due mainly to the new regularity constraint and the fact that the business is growing more and more. So these fragmentations comes with a cost and make our risk system under pressure. So despite the size of our infrastructure, we're facing serious limitations. The first, we had a limited data center capacity. So we simply, we don't have enough resources in terms of hardware and license to keep up with the growing demand. This creates a wait list. Users sometimes have to wait minutes or hours to run their. We were also facing bottlenecks where certain calculations was taking too long or block others. And because each business line use its own grids, so our resources are not shared or mutualized. This leads to inefficiency and with some grids that are overloaded, and we have other grids that are underused. So as you can see, all these limitations are not just technical issues, but we are talking about blocking point for the business. As a result of these limitations, we're facing three major problems. The first one is the obsolescence. On equity side, we had the hard deadline due to the licensing because it's becoming to renew or to extend. It's becoming expensive, and with the legacy middleware, we don't have when we started the study, sorry, we didn't have an operational model adapted to the cloud. The second limitation, it is the business growth. We cannot support all requirements coming from the business. So new product model change or regulations require more risk analysis, and we don't have the capacity to deliver. And the third obstacle is and with this limitation, we had an obstacle to innovations. So teams cannot experiment or launch new models easily because running new calculations is slow, and sometimes it is not possible. So as the conclusions, our historical risk management and the pricing infrastructure was no longer fit for purpose. And to support business ambitions, we had to modernize. And the key drivers of our success was to implement solutions that is scalable, flexible, and efficient. So if you can just please, Jérôme, move to the next slide. Thank you. So in this slide, so as we saw in the previous slide, our legacy grid infrastructure was reaching its limit, both in terms of scalability and operational complexity. So this slide introduces our transition to toward a more modern, scalable and flexible approach based on ArmoniK as a grid orchestrator, by moving away from fragmented on-prem only setup to mutualized and virtually unlimited computing environment. We unlock the ability to dynamically scale across cloud and hybrid infrastructure. So this is not only reducing our cost, but it simplifies as well the operations, and we meet increasing business and regulatory demands with the greater speed and efficiency. So as you can see, two major projects have been migrated and they are live in production since 2022. So we're talking about the equity pricing services. So for this part, we have replaced ArmoniK Data Synapse by ArmoniK, and and we have also the fixed income pricing services, where we have shifting from Data Synapse from IBM Symphony to ArmoniK. If you can just go, please, Jérôme, to the next slide. Thank you. Yeah. So the migration of the first milestone took less than 2 years. It could appear as a long period of time, but we had to deal with other challenges. For example, the first one is to migrate all our libraries and services to Linux, as ArmoniK is running on Kubernetes. And the second one, it was the cloud discovery, as the grid was the first use case on CA-CIB side to be deployed to the cloud. And we had a mini challenge to do mainly on the infrastructure side. Yeah. So as any strategic project, there was some standard process to be checked and done before the go live, including the technical study of the existing architecture, the definition of done, and the success criteria with the business. By business, I mean quant team, front office, and the risk department, and IT as well. And there was a process to make sure that in terms of securities and compliance are okay. Then there was the first implementations or the implementations of the first POC to ensure that the solution that we are implementing is working on both on-premise and cloud side, regardless the provider. One additional point to add is to make our migration to ArmoniK smooth. So on ArmoniK side, they have exposed the same API as we had before in Data Synapse to call Data Synapse and IBM Symphony. And as soon as the production has been done, then we have switched on both pricing services, I mean the equity one and the fixed income one, to initialize interface, so to use exactly the same API. Yeah. And during all this period, we had assistance and support from ArmoniK teams and from AWS as well for the cloud part. So in terms of migration, so as of the end of May, on equity side, we have migrated almost 100% of our end-of-day production, mainly the job that we are running for the trading and for the risk department. And now we are working on the migration of the intraday workload. So mainly for the traders during the day.
Omar,
on fixed income side,
Omar,
yeah.
Sorry, there is an echo. I don't know if you hear it, but when you speak, your sentence is reproduced with a lag of 1 second or something. So can you try to mute and unmute your mic? Maybe
give me 1 second.
Okay,
I don't know if it's better.
Yeah, it is.
Okay. I don't know if I have to repeat everything or we can just.
No, I think it was understandable. So no, it's okay. It was just for the last 3 sentences, so it's okay.
Okay, so I was saying that by the end of May, on equity side, we have migrated almost 100% of our end-of-day jobs in production, and we start working on the intraday jobs. And on fixed income side, works are actively in progress to achieve the migration by the end of the year. So this started by the desk of FX options, and works are in progress to migrate structured and cross-asset perimeters. If you can just please, Jérôme, move to the next one. So in terms of workflow, so as you can see in the schema that we have at the right, and to simplify, users are sending pricing requests to some of our custom services. Then we retrieve data from the provider. I mean the info booking system or the golden source of the market data and the pricing parameters. And then based on the use case that we have, the tasks are either submitted on client side when the graph is static. So this is the case for the equity, or it's called the graph could be built dynamically depending on the scenario that we are running. And this is the case for the fixed income part. And then as soon as the calculations are done, but then the results are collected and sent back to the client. Just few words regarding the graph that we are using on CA-CIB side. So on equity side, we have what we call the packing strategy based. Give me just 1 second, just to highlight. Yeah, so on equity side, we have what we call the packing strategy. And in this, it is based on what we call the resolving of the scenario. So for example, if we would like to run Ovega on 10 matrix, for example, if we have 10 strike and 10 maturities, then we are doing some grouping depending on the estimation of the unitary price durations to ensure that each task that we are running and submitting to ArmoniK, it will take or short take less than 10 minutes, for example. And then tasks are sent to ArmoniK. On the other hand, I mean, on fixed income side, tasks are dynamically created because of the subtasking methodology. For example, if we want to calculate the same Vega on fixed income side, we just send the request to the grid saying that we would like to enable the subtasking. And in that case, the parent task is creating subtasks as many as the number of the sensitive point of the matrix. And we have one more task to do what we call the aggregations. So what is interesting as well is in that case, and if we need some temporary calculations, we have a sort of set cache, get cache mechanism to retrieve the intermediate data when they are available to avoid unnecessary calculations. For example, if we would like to calculate a Volga, in addition to the Vega, then we have we generate another level of set of subtasks for the Volga, and then we could use the initial Vega that we have calculated previously. And then we do the aggregation of both the Vega and Volga. So this is just a simple schema of what we are doing in terms of. And regarding the workload that we are sending to ArmoniK, so we are talking about a dozen of million of tasks per day, many dozen of thousands of our CPU, and we are sending hundreds of gigabytes in terms of data. So for our day-to-day use, and ArmoniK simplifies our use of the grid and make it more configurable. For example, we can adjust the sizing of the pods. For example, on equity side, we are using the partitioning feature implemented in ArmoniK. And in each partition, we can define the limit in terms of RAM and the vCPU to be used. And we are using, for example, the huge pods with a multiple, for example, it could be up to 16 vCPU, and we can use them, for example, for the complex case where we need, for example, to do the multi-threading. And we can use the small pods for the standard case, let's say. We can adapt the provisioning to optimize our costs. I mean, we are using massively the spot instance for the end of the calculations, as there is no real constraint in terms of SLA. I mean, we have all the night to do our calculations, and we are using the on-demand instance for the critical component, mainly for the infrastructure part. And we have another set of another partition with the reserved instance, and we are using this part for the component that we need to be up all the day, for example, to do our intraday calculations. The other point is that ArmoniK offers choice in terms of cloud services customizations. For example, on equity side, we are using ActiveMQ in terms of queue, and on fixed income, we are using SQS. The same for the external data. So we are using Redis on equity side, and we are using Couchbase on fixed income side. And for the internal payload, we are using the S3 on equity side, and we are using Redis on fixed income side. The other point that simplify, let's say, our life when we have integrated ArmoniK, it is the continuous integrations and deployment. So we are upgrading ArmoniK almost once per month, compared to a long cycle for the legacy middlewares. It could be up to 1 year or more. And as I said before, so with ArmoniK, we can handle more some complex graphs. And as well with ArmoniK, we have, and the cloud, we have more flexibility to align business requirement with the faster time to market when adding new workload and simplify model changes, for example, and validation cycle. And just the last point, it is in terms of observabilities and monitorings. We are using a web interface developed by ArmoniK team to monitor our production. So it is used on daily basis by L1 support, and we are using as well some API exposed by ArmoniK to retrieve some metrics and KPI that we are sharing on regular basis with our business. So we are now live in production since a few months, and so far the production is stable with few incidents in production, and we have a close and reactive support from ArmoniK teams since the beginning of the project. So that's all on my side, Jérôme. So back to you. Jérôme?
Yes, I tried to mute.
So thank you, Omar, for the presentation. So I'll rewind a little bit the few messages that you have to keep. ArmoniK is task-based programming model, so you can express tasks and data into your application. It's scalable. It's serverless computing. There is a complex graph dependency that you can use, and it is dynamic. We support data management for you, and we optimize everything that you can do with the computations and the data that you provide to ArmoniK. We support computing on heterogeneous resources, ARM included. We use the cloud native approach based on Kubernetes. We can run wherever there is a Kubernetes, and it's self-healing with resilience mechanisms that are everywhere. So if you have any question, we are there for you.
Yeah, hi all. There were already some questions in the chat where we try to answer live. Thank you, Wilfried, to have done so. I did myself also some high-level answers. So, do you have any questions, whether to Jérôme, more on ArmoniK, or to Omar on more the usage that they have done at Crédit Agricole? If it's the case, then please write in the chat so that we try to answer. And while maybe some of you are trying to write some questions, what we can say, sorry, what we can say is that so it's in production for almost more than 2 years at Crédit Agricole, and there is another French bank, Natixis, that will go live this summer behind Murex on GCP, which is live also a certain workload at Crédit Agricole, and several European banks are doing some proof of concept. So we will be able to announce before the end of this year a few other clients. There is a question how this systems is used for traders in intraday. So maybe, Omar, this one is for you.
Yeah.
Coming back on the slides where you express the different types of people using the ArmoniK. So maybe you can take this one. How is this system used for trader in intraday? Omar.
Okay, so as I said before, so our first milestone it was to migrate all our end of the production. So this is give me 1 second.
Omar,
yeah, can you hear me?
T'étais en mute ou pas toi? Ok.
Can you hear me, Thierry?
Alors mais attends, parce que
I think that there is a problem on your side, Thierry.
Yeah, it was complex. I just put the speaker. So can you answer this question, please? Sorry for the technical bug.
No problem. What I was saying is our priority it was to migrate our end of day jobs. This because this is the huge workload in terms of CPU and data transferring. And as if we talk about the equity case, for example, so we just finished the migration of all the end of day part, and we have started for the intraday part. For the intraday use, we have to distinguish two use cases. So the first use case is when the trader run calculations that are taken sometimes. So for example, we can run delta, gamma, vega, etc. So it means that there is no constraint. We have constraint in terms of latency, but the job could take a few minutes or hours depending on the usage. So this is, let us say, it is similar to end of day case, but we have to be more reactive. And so to make sure that when we run jobs, we can have we can finish it quickly. So I mean, as soon as we provision the pods, so we are using the partitions. I mean, for traders, we have one partitions for all the intraday calculations. So like that, we are sure that when one trader run jobs, so we are sure that it won't impact the calculations that we are running, for example, for the risk departments. When we talk about intraday, so we're talking about all the day. What we have to understand is on CA-CIB side, so we have traders in Asia and others in Europe. So it means that traders, for example, in Asia can run jobs during the morning. I mean, the morning on Asia side, and during this time we have jobs and the end of jobs that are running for Paris risk and trading. And by splitting the jobs by partitions, we are sure that we are provisioning the pods for both, and there is no concurrence between both runs. So this is the first use case of the intraday, and the second use case is when we do what we call the RFQ. I mean, we have just a simple RFQ. I mean, request to price, and we have to answer as quickly as possible. So in that case, what we are trying to do is to implement another partition where we use reserved instance, for example, on AWS side. So by provisioning the reserved instance, we are sure that we won't have to spend much time or a lot of time to do the provisioning of the pod. As you know, so when we provision, when we are doing the provisioning of the pod within AWS, we have to wait sometimes to have pod up and running, etc. And then we have to do the same as soon as we have RFQ coming from trading. So just to sum up, so we started the migration of the intraday. We are using a different partition for the huge calculation that we are doing in intraday to make sure that it won't impact the run that we are running for the other departments or end of day. And for the RFQ pricings, I mean the requests that are not taking a lot of times, we are running them. We run them on AWS, and we are using a specific type of instance for that case.
Okay, thank you.
Hopefully,
There are two questions, so I will catch the first one. There is a question from Abhishek asking how XVA Monte Carlo calculations for many counterparties will be handled here. So Jérôme, you can go up to the previous slide. So a quick answer is that there is this pricing services that mutualize all the pricing done by all the applications. And this pricing service then delegates to ArmoniK the spread of all the pricings onto a grid. So XVA is a typical here the market and counterparty risk is a typical application that is client of pricing service, and that will then use ArmoniK to spread all the computes on internally on prem or to burst onto any cloud that would be available. Today it's AWS, tomorrow it can be GCP or IBM at some point to please the Martin. So I hope this answers. Then I will try to unmute Nave that is trying to ask some questions. So Nave, you should have the mic open now.
Can you hear me, guys?
yeah.
Yes, we do.
Yeah, thanks for this opportunity. I have a question, like this is more about quant trading.
Sorry, can you repeat? Sorry.
It is more about quantitative trading.
Is ArmoniK more dedicated for trading, or?
Yeah. My question is that is this quant trading, right? Doing analysis of trading patterns through Monte-Carlos.
Yeah, so I will do a quick answer, and Omar, you can complete. The quick answer is that definitely the people that will use ArmoniK are the quants, because you can just use the APIs of ArmoniK to activate the graph functions, and then in Monte Carlo, Nested Monte-Carlo, you can just choose at which time you want to use which type of partitions and so on. So And these features can then allow to put the parts of the algorithm to the right partitions, whether on-prem or on cloud. And ArmoniK takes care of optimizing the infrastructure, the partition infrastructure that you have allocated to this part of the compute, and optimize the data and compute transfers. So as Jérôme has explained, there is this pipelining that puts a usage of CPU or GPU like close to 100%. And so yes, definitely the persona we target for ArmoniK are the quants that when we say at the beginning unleash innovation, it was for specifically targeting the quants. So yes, it's a tool that can abstract a lot of the IT burden that with all the closed source orchestrators like Data Synapse or Symfony, all the IT quants people that were obliged to do a lot of scripts and so on because you were obliged to cut into partitions and so on. So all this can be abstracted. You can dynamically invoke the partition. You can just dynamically pop up the machines you want depending on the workload of the use case or of the pricing. You can put that on-prem for live trading because you want a certain fixed answer, or you can put for more the end of day or overnight batches on cloud to get cheap spot instances, for example. So I hope I do answer your question, Navé.
And just to add one more details, so all the calculations that you can see here, I mean in terms of var, SVAR, cross-VS, sensitivities, etc., are calculated by the library developed by the quant team. And the results are used by the trading and the risk department.
Okay, I'm trying to see if there are extra questions. Sorry, we are facing some technical issues. Are there other? Yeah, there was a question about is ArmoniK more scalable or mutualized than Symfony, where Wilfried did answer in the chat saying that you can federate as many grids as you want as a single meta grid. So it's a kind of meta orchestrator, and there is no limit, no technical limits on the. You wanted to share some code.
Yeah.
Navé, I think it was for you that Jérôme wants to share this small example. So I think there is another. Okay, Martin, thank you for your comment. What about forecasting abilities on the platform? How can we backtest the CCR model? So keep in mind that, so the question, I recap it for everybody, and I will give the hand to Jérôme to explain a little bit the Python code he is showing. So the question of Abhishek is, what about the forecasting abilities of the platform? How far can we backtest the CCR models? So once again, the aim of ArmoniK is for the guys writing the models, writing the risk application, to be able to have a hybrid orchestration of an unlimited number of clusters or partitions on-prem or on cloud. So the abilities, the technical abilities, so far we have not reached the upper limit. We know that there are some limits, but I don't know if you can answer more precisely, Omar, on this question of the CCR model, but to me, don't misunderstand. We give a technical tool that really manage orchestration and abstract the burden of the infrastructure, allowing cloud, the quant, to really play with infrastructure as code inside their code. So I suspect you want to show this little example, Jérôme.
Yeah, so basically, we are working on the Python SDK that simplifies a lot how to implement tasks and distribute them on ArmoniK. So basically, the idea here is that you can write your Python code, decorate it with decorator, then use well, a context in Python, and you can just invoke your functions and write its results. And the function is written, it's written on your client side. It's sent to our workers, executed, and the result is taken back here. So basically, you can write your Python code as usual and distribute the task and make computations on ArmoniK, then retrieve the results. And here's the documentation of this Python SDK. And you can also define graphics, like I said before, and it's very convenient to use.
Okay. I'm looking at the chat, and I think there is no extra question, unless I missed one. Sorry. So we are close to the end. We just made a record. We were contained in a 1 hour session, including the delay for the start. You will find this recording in the armonika.fr website. We will try to do some advertising of this once published through LinkedIn. So most of you have, I think, have registered through LinkedIn. So you will see this popping up. And for technical questions, we would be very pleased to answer you because we are a team of very talented and passionate people that works on this orchestration. And so we thank you a lot for your attention. Omar, thanks a lot because you are a very pleasant client, and we did a lot of very interesting things with you. And I remember Crédit Agricole is the founding partner with AWS. So thanks a lot for this adventure. And
sure.
Jérôme, thank you for the presentation, and happy to talk with the ones of you that were interested by what we all say. Thanks a lot to everybody, and have a nice evening wherever you sit in India, Europe, or in the States. Okay, cheers.
Thank you.
Thank you. Bye, everyone.